Here is an example of a suction network project. We are going to see how a network is passed, in suction or in discharge. So there, we built a small network of aspiration. I take this opportunity here to point out that the orientators are used to position elements. So there, I select an orienteer. And if I change the orientation, I change the orientation of the element. But in this case, this orientator is absolutely useless, because the elbows are orientable. We can therefore obtain the same result without an orientator. So we remove the orienter, delete, I select the elbow. And it's him that I'm going to orient. And so I orient the elbow at the desired angle, 90 degrees. So, it was just information. We are testing a flow of 1000 cubic meters, here the network is in discharge. So we test the speed. Here is the result. So we see here the different pressures in the different parts. So we enter the atmospheric pressure, and we generate a maximum of pressure just at the generator outlet. The pressure therefore changes in the pipes. We're showing an animation with particles. And so here we see the system at the backflow, with the particles coming out of the lattice. We note here that the particles therefore descend. The circulating fluid is air at 20 degrees, and the external fluid is air at 20 degrees. So the particles come out with a certain inertia, stop and pile up at a certain distance. When the density is changed, the particles react differently. So I'm going to select and pass 60 degree circulating air. In the Fluid Modification tab, we will select air at a temperature of 60 degrees. Use this fluid, yes, 0 altitude. OK. We return to our synoptic, and we restart the flow calculation. We will see how this variation in fluid temperature will modify the result. The fluid becomes slightly less viscous with increasing temperature. So we will have a little less pressure drop. We will notice the way the particles are ejected. Therefore, the circulating fluid being hotter, it is lighter than the external fluid. We therefore see the particles at the exit going up with a difference in density between the outside, which is at 20 degrees, and the circulation flow, which is air at 60 degrees. This is the interaction between the circulating fluid and the external fluid. Now we are going to switch to aspiration mode by selecting this option. There, we have to restart the test flow. Before we had a generator pushing back into the pipes. Now we have switched to suction. And so here we have a system which sucks the fluid through the different inlets. We see that the whole network is in depression, with maximum depressions visible here. We're going to do a trajectory test. We can clearly see the particles sucked into the network. So with the effect of the density delta between the ambient fluid and the external fluid, we have a column of air rising. We can have fun modifying the circulating fluid again. To put it at a lower temperature than the ambient fluid. And therefore put the fluid circulating at 0 degrees, which will be heavier. We restart the test. The fluid at the exit leaves and goes down again. This example of network option, in suction or in discharge, with the Mech-A Flux Pro 3D software ends here.